Everything else has been sort of like regular level of difficult. This one's kind of more difficult. Anyway, what we're going to do is we're going to select the correct explanation of the geometric proof that it's asking for that uses a transformation. So we've got line MP and line NQ intersecting at point O right here. We want to know which rotation can we use to prove that angles U, this red angle, and V, this green angle, are congruent, and why. So I'm going to put up a poll, A, B, C, obviously A, B, C, and I want you to pick which one you think is going to work to prove that this angle U is congruent to this angle V. They are all the same thing, it's just different measures of the angle of rotation. So this is measure of angle U, measure of angle W, or 180 degrees. So we just need to pick the right degree angle of rotation to map our angle U to angle V so that we can see that they are the same measure. We just need 2 more responses. All right, so the one that got the most votes is B. We'll try that one first. Angle U is this little guy. So if we rotate ray OM, the measure of angle U, it'll land on ray OQ. Right, so point M will go to about where point Q is. And let's see. So it says that it would map ray OM onto ray OP. So that rotation by the angle U does not do that. It only it only maps. It's fine, guys. It's all good. Maps OM to OQ. So this is not true. So since it says the wrong thing, we can already tell this is not the correct angle to rotate by to get U to V. So B is not our correct answer on this one. Let's go ahead and look at the one that got the next most votes, which is A, 180 degree rotation about point O. So we're considering where it maps ray OM onto. So 180 degrees would take M all the way around about to where P is. So that first part is true. Maps OM onto OP, so that's good. Vice versa means the other way around, so it should also map P to M, which it does. So P prime's here. Okay, so that's good. And then the same for rays ON and OQ. So ON, we've got that one. If we rotate it 180 degrees, N will land about where Q was, so that's good. We'll call that N prime, so that's good. And if we do that with that way, it should also map Q about to where N is. So that's good, which means angle U will be mapped onto angle V and vice versa. Vice versa, if I didn't already say it, which I think I did, just means the other way around. So this one does work. We map with 180 degree rotation OM to OP, OP to OM, ON to OQ, and OQ to ON, which takes angle U to angle V. So I think this one is our correct answer, but just to be sure, we'll check the third choice as well. So this one says a rotation by the measure of angle W about point O maps ray OM to ray OP. So Angle W is this big, so it would map ray OM. Let's see, how big is this? Like that much, maybe? It maps it to like just the middle of nowhere. So I don't think this one's gonna work based on where it maps M to. Right. Does anyone have questions about why we've chosen A for this one and not B or C? Right, so on this one, we've got line L. This one is a perpendicular bisector of segment AC, and D is any point on line L. So they put it here, but it could be like here or there or up there or like way out here if they wanted to. They put it here because it was convenient. And we want to know which reflection in the plane can we use to prove that D is equidistant from A and from C, so that this is the same length as this. So goal, I like to write out my goals when I'm doing a proof. AD equals DC. In other words, we want this to be congruent to that. Still need a couple more responses for how we do that. And based on what it said in the problem, L is the perpendicular bisector, so AB is congruent to BC. That is given. Given AB equals BC. Still need one more response on that poll for which one we think is going to be the correct proof using a transformation. One more response. Nope, we got them all. Alrighty. So the most popular choice was B, so we will start with that. And B talks about a reflection over the vertical line. Okay, so up and down line passing through point B. So we'll pretend that that's a line and not a squiggle. The vertical line through point B maps point D. No, wait, maps point A to point D. So for this point D, that could work. But what if I had point D down here? Because remember, D is any point on line L. So if point D was down here, would A reflecting across this vertical line map it to point D? Can anyone tell me in the chat? If my D point was down here and I was reflecting across this vertical line, does point A still land on this point? Anyone in the chat, maybe? Anyone? Remember, when we reflect across the line, our points have to go to the other side of it. So if we're reflecting across this vertical line, point A will definitely not land down here. It's on the same side of the line of reflection, so that can't happen. So we can eliminate letter B. That's not the correct answer. The next most popular choice was letter C. I'm going to erase the thing that I wrote there. Did I grab the right color pen? Oh, close enough. All right. So up next, we want a reflection over line L. So the line of reflection is this perpendicular bisector of segment AC, which will map point C to point A. We know that that's true because they are equidistant from the line and perpendicular to it. So C prime comes over here, A prime comes over here, A prime over there, and we can see since C prime landed where A was, the distance from D to A must be the distance from D to C. So that does make sense, right? And since D to A over here is the same as D to A prime, because reflections preserve distance, we know that that one does work, that one makes sense, must be true. Just to be sure, because a couple people did vote for A, we'll go over that one as well. Let me just erase these things I wrote. And we're looking at letter A now, which says a reflection over line AC. It's this line, if it continued on forever instead of being a segment. It says it would map point D to another point D prime on the line L, map point C to itself, also true. It says because reflections preserve distance, D prime is also equidistant from A and C, but we don't know that D is equidistant from A and C, so this assumes the thing that we're trying to prove. One of the main rules of proofs is that you can't assume what you are trying to prove. It is a logical no, you can't do that in logic. It's against the rules. You can't assume the thing you're trying to prove. So letter A is incorrect because it is assuming the thing that we're trying to prove, our goal, instead of starting with what we were given. So you always want to start with the stuff you're given and work from that using things you know to the thing that you're trying to prove. So that's why we can't use letter A, because it assumes our goal. Top voted choice was B, this one. So a translation along the directed line segment ML. So that is a translation that brings point M to where point L was. So that brings M to here. We'll also bring N to about there. Bring L to about here. K about there. Draw that line. Pretend I can draw straight lines and points in places where they need to be. And of course it would take point O about up here. But what it's going to do is it'll map angle U to right here and angle V to right here. So that really doesn't tell us that they're congruent. It just puts them in different places. It moves V to be vertical to U, but we're not working with that right now. So this one isn't going to work because we really want V to land on top of U. So A and C on that actually got a tie, 5 votes each. So I'm going to put up another poll between just A and C to see which one has more votes to get angle V and angle U to show that they're congruent. All right, angle. Choice A got the most votes on this round, so we'll look at that next. We want to do a reflection over a line through O that is parallel to lines KL and MN. So this is the line we're reflecting across, which would bring point N up to here and point M up to here. And it says it would map LK onto MN and vice versa. So ray M prime N prime goes that way instead of the way that LK does. So this isn't looking good. Oops. L prime, K prime. So it says it should map ray LK onto ray MN, but we learned earlier, right, that the direction and the order of the letters for array matters. So LK is actually not mapped onto MN. It's mapped like facing the wrong direction, starting at the wrong point. So that one doesn't work. So we can't do that because it doesn't map the way that it says. Which leaves just one more choice, our 180-degree rotation about point O. Let's see, what color should we do? I really like orange, so we're going to do orange. So we're rotating 180 degrees about point O. That'll take L right to where M is. That's a good start. L prime here. Bring M to where L is. M prime here. It'll bring K to somewhere near where N was. So K prime's here. It'll bring N around there. So basically, it's going to take all our points and it'll put them in the opposite spot, except O will stay where it had started from. I'll erase these circles because they're kind of confusing. Do 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 do. That's L prime, that's M prime, K prime, and N prime. All right, so 180-degree rotation brings all those points here, and angle OMN becomes angle O M prime N prime, this angle. So what used to be angle V is now where angle U is. That's good. We want that because we want our angles to map to each other. And angle, what used to be OLK, is now OL prime K prime, which is angle V has mapped, or what used to be angle U has mapped to where angle V is. So this looks like our correct answer on this one. We want to rotate it 180 degrees to prove our alternate interior angles are congruent. So we will start with that. B takes our translation along the segment AC. So that brings A to where C is. Interesting choice. So let's see it. I think that'll bring B to about where D is. F down to like right there. And it'll bring E down to like right there. So we'll have like, and it'll bring C to like right here. So we'll have this new line. We're going to pretend I did a good job drawing that when I really did a bad job. It's fine. It's no big deal. Alrighty. So then we've got, our transversal will also be mapped. It'll go now through here. I'm really bad at drawing, friends. I'm so sorry. All right, so that's taken angle Y to here, angle X to here. That doesn't really help us much at all. So I don't think this one can be the right answer. We really want X or Y to land on top of the other angle. We want one of them to land on top of the other. And this one, we also have a tie for A and C, so I'll put up another poll. Do we want to go over A next or C? Which one do we think is right? Are we mapping A to B or C to B? All right, we got 10 votes for A, 9 for C, so we will do A next. A is a translation along directed line segment AB, so that takes point A to where point B is, which will bring point B over to like here. D, C, label that, E over like here, and F like down there, brings our transversal to like, oh, that was really bad. All right, this is not going to be any better. Bring it like that. So it moved everything over to the side a bit, but angle X is here now, angle Y is here now, and I still don't see how that's going to help us prove that X and Y are congruent because it's not mapping one of them onto the other or anything. So I don't think it can be this one either. We'll go ahead and erase that before we go over C, which maps with the translation C to B. So point C will land where point B is. Once I can finish erasing this. Slow eraser. All right. Maps point C to where point B is. Okay, that looks good. Point D, well, that's going to go over here. It's not really relevant to what we're looking at. Point F, about down here. E, like up here. So that takes this angle FCE and moves it up to here. So angle Y lands on top of angle X. That's what we want. I think that is the correct one because it actually does map our angle Y onto our angle X, which is the goal. We want X and Y to be congruent, so we want to map one onto the other.